Good evening, ladies and gentlemen. Thank you for giving me a voice. I will to talk today about methane production, biogas fermentation, and today's topic would be the preparation and checking the substrate availability on basing of articles of Professor Holliger from Lausanne University, first from 2016, which was with cooperation with Denmark Technical University with Professor Angeli Daki and a professor from Paris University, Thierry Bayro, and then this is towards a standardization of biomethane potential tests. And 4 years later, there's Professor Holliger, with cooperation with Leipzig University by Professor Hafner, he checked this summary power limitation of biochemical methane potential test. First is using the test where article is showing the big checking of method, which is testing the substrate for methane. Why is so important? Because to making interesting the banks and industry to use biomethane, you needed to make it more industrial. And one is possibility which waste are better and worse for methane. The mixing was several hundred, so for several hundred experiments to make how this checking, how the error is made and when is suitable, and produce a protocol for methane. There were several forms. One is 2 by 1,000 form, but this leaves much difference in test of methane fermentation. This shows the association make big deviation in the repeating. Therefore, the tool should be eliminated big deviation to have big repeat. As the result of this test, that validate biomethane test, all tests must be carried at least and triple every experiment, which is batch, assay checking. How to experiment must be typically. So we have several tests and needs to be repeated 3 times if the methane is production is repeated, then it's fine. The better biomass methane biomass methane potential is using substrate besides several blank assays which check only inoculum. The duration shouldn't be fixed advance and should be terminated when daily methane production in 3 consecutive days is less than 1%. The biomass methane potential volume of dry methane is using the standard conditions, so 27 Celsius degrees and 1 atmosphere. And the volatile solvent added. The test should be a possible control for calculation. We need average, substrate, and blank, and with mistakes. The test result must be rejected if one of control gives higher than 5% error. In the case of homogeneous 5, in case of heterogeneous substrate, is higher because much lower, even 10% error is suitable. Then the continuous method continues because batch biomethod for metal potential uses batch as the first step to use in continuous way. So closed reactor, and if the result are from by experiment are positive, then we expect that in continuous way would be 85% to 100 in 2016. But later in 2020, he shows that in case of continuous, there is not always, because the test doesn't give any solution of what organic load should be added in 2020 and what how much added of nutricity and good for mixture, and but in case doesn't show stability because due to no hydraulic retention time, we need to make a test which helps, and this needs to be improved in future tests. But we coming back to the 2014 16, the required in methane production is usually pH kept from 7 to 8.5, and volatile fatty acid should be lower than 1 gram per liter if is used in good methane. It's not so have to be this converse to methane. The alkalinity needs to be higher than 3 grams of calcium carbon dioxide salt, 3 grams. Ammonium needs to be lower than 2.5 grams. These conditions shows that biomass methane potential is quite well. But it doesn't show that in some cases, in case of acidogenesis of hydrogen traffic, can be lower. So this PAD in 2016 was an exception, which shows in 2020, especially in mixture. It shows big diversity. The mixture digestion is not prolonging, only some hints, not big problem. How we prepared according to norm the inoculum. The inoculum should be as much as possible be used as sampled. The inoculum needs preparation. So we get inoculum, for example, for wastewater seed management, then sieve, dilute, and pre-incubation. Coarser material, if present, first we sell some sieving. The sieving of inoculum is from 1 to 5 millimeter match screen. And that mesh screen is sieved. This is allowing that inoculum will be in liquid and not any other waste from waste management. So waste of other using of living sample. This show that will be only bacterial layer. Dilution shouldn't be avoided if according to volatile solid content. If it's too high, the inoculum can be diluted and nitrogen flushed in water. Inoculum cannot be washed since this removes some nutrients and vitamins. In the case of dark fermentation, after this using, we use heat processing, but the formula wasn't for hydrogen production, and 2020 also because I catched in methane potential. And is assumption that is a coction. So the inoculum would be not pretreated by anything by itself. Then after sieving, and we will be using stress should be stored at test temperature, at least ambient temperature, for 5 days until have been determined. Then storage at low should be avoided. But this option that certain can be stored for 4 degrees. Therefore, substrate sample must be representative to be digested in full scale. According to base assumptions should be available substrate to the at full scale. The preparation after shredding this is to 5 liters. In case of sample, the sample for methane is this for substrate. It should be less, mostly between 10 millimeters or lower, and this is the barometer, lower or mild, and the substrate sample should be stored at 2 to 5 days before experiment. It can be also freezing in -20, but careful not to destroy, and this destroying can be as per treatment. The substrate analysis should be made by Kjeldahl and ammonium test. The Kjeldahl shows how much nitrogen, how much ammonia is inside the sample, initial, and volatile fatty acid. So we know how in the beginning and after, how we know how is removed these acids, and this is one characteristic that shows the results. The test setup should be commonly used as gas production. The reactor vessel should be adapted in small volumes from the volumes between 200 milliliters to 2,000 milliliters, but usually at 500 to 2,000. The sodium bicarbonate should be added at least 3 gram. Phosphate buffer shouldn't be used. And for preparation, the test batches, we need to be gas by a gas analyzer or gas chromatography or both. Gas analyzer try is fast and shows us the hydrogen sulfur. In case of gas chromatography, we need to combine techniques, but flame techniques, flame ionizer technique, or thermoconductive detector to be used as for the mention, but requires hydrogen sulfur different cores. So the sample needs to be through different cores to be detected. Positive control gives us the solution as how much is presented, and this shows show how we make. This method is commonly used and very simple to check how given substance is available. It was in 2016. In 2020 was this summary, and this was the solution. As I mentioned, it wasn't good for in case of changing the size. It shows that in case of mixture, it has big error, and in case of uh, organic load time, and it wasn't very enough. It needs to be changed. Their technique to or maximize to optimize in this case, and this is show how we should change the temperature of inoculum in keeping should be for thermophilic or mesophilic. In thermophilic 55, in mesophilic 33 or 40. As I said, hydrogen retention time, hydraulic retention time. So how much should be flowing the liquid for substrate to be enough? And the trouble is that the toxic substances are very harmful, not showing because a big difference. In small is so pinch that in long exchange it should be harmful. So this is the trouble in case of changing to methane, the waste which comes from which has much antibiotics. So manual with industrial farming where use much antibiotics and can be toxic, and this is the trouble which not shows, which can be not detected and received in this biomethane biogas methane potential test, and this should be detected how to check, how to remove, and how to make influence of these substances, which can kill biological layer and influence in case of scaling up. But this shows that the good requirements is used as useful, for example, in biogas plant used in city of Berlin, which several waste. And of course, there are high research focus, which changes also both in methane and hydrogen production. And thank you very much for listening to me.